Welcome viewers in my presentation on fundamentals of CNC programming. In my lecture on CNC machines, I have told that every actions in CNC machines are taken by some alphanumeric characters. What is alphanumeric characters? Alphanumeric characters mean alphabet as well as number. As well as numbers. So, at the initial developmental stage of CNC machines, there are some programming technique we call fixed sequential format. Then have come tab sequential format. Tab sequential format. Then word address programming. In abbreviated it is called WAP. In fact, in almost all CNC machine now it is using word address programming. These two types of programming technique becomes invalid nowadays. Nobody is used this. No manufacturing is following this programming technique. Today I will discuss this one. This one, word address programming. In CNC machine, almost in every case, any positions is calculated from a reference point. This reference point is called origin. As it is automated, so suppose my tool movement, my tool has to go from this place to this place. So, I have to give this coordinate system, then this coordinate system, then this line is defined. Of course, if it is a straight line, this can be here, this can be various techniques. Then I have to mention that it is a curve or it is a straight line. In CNC machine, all these coordinate system is followed by Cartesian coordinate system. In Cartesian coordinate system, you know, the first I have to define a origin, then right hand axis is x axis, left hand axis is negative x axis, y axis and negative y axis. So, here this is, you will see, this is just Cartesian coordinate system, x axis, y axis and z axis. Now, if I want to classify CNC machine can be of 2 axis CNC machine, can be of 3 axis CNC machine. So, 3 dimensional coordinate system is required for 3 axis CNC machine. What is 3 axis CNC machine? You will see a milling machine is basically a milling machine is basically 3 axis machine, 3 axis. In cases lathe, most of the lathe, it is basically lathe machine, it is basically 2 axis CNC machine, it is basically 2 axis. So, in case of lathe I have to follow a 2 dimensional coordinate system. In case of milling I have to follow 3D, it is basically 2D. Here you will see that this is a 3 dimensional coordinate system. Now, what should be the, which axis? It is x axis, it is y axis, it is z axis. But in CNC machine, which axis should be assigned as x axis and which axis should be assigned as z axis? As I told you in my lecture on CNC machines, that it is internationally accepted that job axis is z axis. So, if it is a lathe, if it is a lathe operation, if it is a lathe, if it is a lathe, if it is a lathe, it is z axis, it is z axis. Okay. And if it is a milling machine, then milling cutter remains like this and your job is this. So, job axis, and so this cutter axis, this is z axis in case of milling machine. And once this is fixed, z axis is fixed in lathe machine, towards the operator it is positive x and towards the away from the operator it is negative x. So, every point is denoted by some coordinates. Here some points, some, so it is as it is a CNC, some coordinates, these coordinates is a positive x, positive y, so and so this. As I was telling you that this figure tells you that this is a lathe machine, that job axis is z axis, towards operator it is x axis, away from operator it is negative x axis, right. So, here the milling machine, vertical milling center, as I was telling you, the convention is that job axis is z axis, this is along this machine it is x axis and this is y axis, right. In CNC machines, I can give coordinate either following an absolute mode or incremental mode. Absolute mode means this is origin or reference point, this is fixed, that is absolute mode. So, suppose I want to, let me show you the slide. Suppose I want to let me give you, this is an absolute mode. You see, I want to drill a 5 hole. First hole, the coordinate of first hole is how much? Coordinate of first hole is here 250. Then every coordinate is measured from the origin, and in case of incremental mode, once an operation, once a drill hole is completed, that point is assigned as 0 point. From this point you have to give the coordinate where you want to further operate. That means, it is a basically instantaneous or relative coordinate systems. Very frequently it is called incremental coordinate system. And so, before programming of any part, you have to first fix this, in which mode you want to program the part. So, this is absolute mode and this is incremental mode. As I was telling you that CNC machine can be classified based on the axis. CNC machine can further be classified by positioning system. Positioning system. If you observe a CNC say drilling machine, CNC drilling is just drilling a hole, then it is going just dry run and again a hole, again a hole. So, this type of machine is called point to point positioning system, as if this is a point, this is a point, this is a point. Okay. In contrast to the milling machine, suppose you want to create a contour something like that. So, every point cutter has to go, every point cutter has to go, every point. So, it is called continuous or contouring CNC machine, that means that is milling machines, right. Lathe operations, it is a continuous or contouring machine, drilling, boring, it is point to point positioning systems. Further this can be classified. So, this is a very simplest type of point to point coordinate system. That means, you want to, if you want to create a hole here, then hole here, then hole here, then hole, then and so on. The first part, this is a contouring part, a contouring example, but it is a difference is that upper part is simple contouring, lower part is a bit complex contouring. Now, in CNC machine, whenever you instruct a CNC machine, what CNC machine what a CNC machine does. Suppose say this is your coordinate system, this is your A, this is your tool has to go from this point to this point, okay? This point to this point. You once you put the coordinate system here and here, how tool will go? First you have to understood how this path is achieved. Given the construction of the CNC machine, two perpendicular type of lead screw where motor is connected at the end. So, my tool can go either this way or my tool can go this way. So, how this angle is achieved? Only it is possible, angular movement of the tool tip, only it is possible if it has to go with the combination of something like that. Okay? Two perpendicular, two perpendicular, two perpendicular, two perpendicular. ठीक है. This, that means I have to know this point, coordinate of this point, coordinate of this point, coordinate of this point, this point. I need to know. I know the start point, I know the end point, then gradient of the line I know. Given this distance, I can easily find out the coordinate of this, coordinate of this, coordinate of this distance, this distance, this distance. Given this distance is same, this particular distance along x axis, this is called basic length unit. This is a characteristic feature of a particular CNC machines. And the method when the intermediate points are computed given the two end points, this method is called interpolation. That means, once you instruct a CNC machine, it needs some time to compute these intermediate points. It needs some time, maybe in microsecond, but it needs some time. This particular, so if you want to, this is the linear interpolation. If it in case of contouring, then it is circular interpolation. If you cut a three-dimensional surface like milling machines, it is a spherical interpolations. So, interpolation is a very important factor in CNC machines. If I observe CNC machine, basically functions, what functions are there? Like this interpolation, another type of functions are there where machine needs to act immediately. That means, if you want to instruct a spindle off, that means machine needs to act immediately, spindle off, coolant on. All these instruction machine needs to act immediately. Unlike this type of functions, these functions machine needs some time to act. So, this type of where machine needs some time, this is taken care of by some codes. This codes of this code is called geometric G code. G stands for geometric code, or another name is there which is very meaningful, this code, or that is why it is preparatory code. Preparatory code. From the name itself we can understand why it is preparatory. Machine needs to prepare itself, and where machine needs to act immediately, this type of code is called miscellaneous code. Miscellaneous code. So, basically there are these things are called interpolator. That is why main function is interpolator, that is why it is called G codes are called interpolator. Now, this is the circular interpolation, as I told you. This one is, see, one is this from the other point of view. Let us how tool moves. Let us take a very simple example, same example once again. Very simple example once again. Suppose this is your tool, cutting tool. Tool goes towards this direction. Tool goes towards this direction, as I told you. Then this direction, or tool goes, sorry, first this direction, then this direction, then this direction, again depth of cut, then this direction, this direction. Tool goes towards these directions. Now, if I consider the velocity of this, in which velocity it will go towards this towards the job, and which velocity it will go towards the job. Suppose an operator is operating a conventional machine. What he does? He initially goes a higher velocity, and when he is approaching towards the job, to touching, the velocity definitely decreases slowly, once then tool touches the job. That means, when a tool should go to approach the job, it is initially a big higher velocity, then reduced velocity. That means, it is going basically approaching the job, it is basically decelerating, okay, and say this is a constant velocity. When it is coming away from the job, it can be a bit higher velocity, no problem at all. That means, thus it can reduce the next cycle time. This velocity can be a higher velocity. This is called, this is in CNC called rapid traverse. Rapid traverse. This depends upon the constructional features of a particular CNC machines. Construction, what are the stiffness of the whole structure of the body of the same machine. This particular figure is, you see, this is this rapid traverse, this is denoted by some G 0 0. Here you will see this is a lathe machine, that just a similar picture, and then this milling tool, when it is away from the job, it can go a bit higher velocity. Like as I told you, straight line movement, like this is a like interpolator, every point has to touch ground at this touch. So, this is a pictorial view of linear interpolations. It is, as I told you, this is a pictorial view of circular interpolations. This is a counterclockwise interpolation, of course, circular interpolations. Okay. Direction of rotations, direction of say this one. This is this end of program, that is this end of program is done, every action is coded by M30, another miscellaneous code, end of the program, pictorial view of this. As I told you that there are, this is where from the coordinate is counted, this is called machine 0, machine 0. ठीक है. So, every actions, whether clockwise or counterclockwise, whether linear or interpolation, every whether it is incremental method based programming or absolute method based program, every actions is denoted by some G code or M code. And once you purchase the CNC machines, in the manual, the list of G code applicable for this machine, list of M code, it is given in the manual of the machines. Though all machines, as all machines follows a international standard, so interpretation of a particular code is same for all machines. All machines manufactured by different company. Machine it will not never happen. It will never happen that interpretation of G54 of this machine is like this, interpretation of G54 this machine like this. It will never happen. It may happen that this code is not applicable, not used in this machine, but it will different meaning, it will never happen. So, program starts by some O or P. In fact, in worldwide there are basically two types of controller used. One is Fanuc based controller and another is Siemens based controller, Siemens controller. Every controller has its own advantages and disadvantages. In industrial environment, in hazardous environment, these Siemens controller used, but in if in AC education environment, it is Fanuc based controller is used. If it is a program starts with O, then you be sure that this program is written on the basis of Fanuc based control system. If it starts P0003, that means if P is there, then you be sure that this program is written based on Siemens controller system. Here it is an example, N01 line number, G90, whether it is incremental or absolute. X stands for here, this in this program X stands for 0 y0, that means it starts, tool move starts from 0 position, z this, f means speed, s means spindle speed ratio, then m30. Now, suppose this is your CNC machine. You have, this is your inside your CNC program. What it is, what is the output of this? So, this is CNC program. This program is basically, say it is a control system. Again it look like a black box. What does it do? The function of this control system is nothing but to send the respective current, to send the respective current x axis motor, y axis motor, and z axis motor. That means, this control system sends the current, how much current, at which time, and at how much period it will supply. It will supply how much current at which time, and how much period, what is the duration of this, how much current goes to x axis motor, how much current time and p goes to y axis motor, how much current time and duration goes to z axis motor. Rest of the things are mechanical. So, whatever you do, the primary objective is this. I am discussing this is manual mode of programming, but there are commercial softwares. The same thing, given the 3-dimensional model of the object, final product of the model object, and the raw material used, this program can be generated by software itself. There are many softwares, say you must have heard Mastercam, EdgeCam, DellCam, all these softwares are used to write down to create the program automatically from the 3-dimensional model. This type of program is called computer aided part programming. So, today I have discussed what are the different methods of programming, what is interpolations, how the order is executed, and what are the lastly what are the other techniques of programming, manual and automatic. I hope you have enjoyed my course. We will meet in my next lecture. Till then, goodbye.